Once again, good evening and welcome all of you. So myself Hari, we are from High Tech Institution. So today you all know we are going to discuss about Project 16. Uh, that is something using namespaces and creating parts in Kubernetes. Okay, literally very first time we are going to talk about Kubernetes in our project journey. Okay, so people who regularly attend, they might know we started from the project 1, 2, 3, 4, 5, 6, like many projects we have completed. So intention for this weekend session is it's totally free of cost, just as a knowledge sharing platform. Okay, whatever I know, I'll try to convey to team. There are some people got benefited. I got personal feedback like they are. This is very much helpful for them to attend the interview and all. So even the people who doesn't have the knowledge in topic, it will be useful for them. Okay, that is the intention. Okay, fine. With that note, we can get it started. The session every weekend, which is happening for free of cost. Any person who watching this video in YouTube, in the description, I have given a WhatsApp channel link. In the WhatsApp channel, go ahead and click the link to join the WhatsApp group. So you can also start attend the session in live. Okay, on the weekend. So if you have any question related to the project, straight away you can ask it anytime. Feel free to interrupt. If you guys having any generic doubt about your career or something, feel free to wait till this session to complete. We have a parking lot. We'll discuss about it. Okay, fine. So in this case, today we are going to talk about namespaces using and creating pods in Kubernetes. Okay, fine, guys. So
Hi,
yeah,
Harish.
first project I think so far whatever the project we have discussed, right? That is all purely into containerization, something like that. We have a couple of containerization Docker-based projects we have seen. Today, it's about Kubernetes. It's day for Kubernetes. So before we get it started with this Kubernetes, right? We all need to understand one architecture level differences. We all should know one architecture level difference. What was there with the hypervisor? What is there with Docker? What is there with Kubernetes? That differentiation, right? We should, everyone has to understand. Okay. So first, let us go through the architecture. Then probably we'll understand this specific, you know, uh, project 16.
Hi, Harish. Hi, Harish. Hello. Hello. Hello.
Yeah. Hello.
Yeah, I have a small doubt.
Yes.
What is the difference between context and a namespace? It is both are same or different?
The difference actually.
May I know that context?
Yeah. We'll start the session. You will understand by end of this. Okay.
Okay.
Okay. First, we'll understand the basics. I have one pre-recorded content available. Probably I'll do that so you guys can understand well. Understanding the. Okay, all of you able to see my screen? The paint?
Yes, sir.
Yep.
Yes, sir.
Perfect. Perfect. Thank you. Thanks for your response. So, I know just next 5 minutes, all of you mute and listen to this carefully. I'm going to compare the architecture between why we are using hypervisor, why we are using Docker, why we need to use Kubernetes. I'm going to complete this in Kubernetes architecture. Okay, I'll going to complete this in Kubernetes architecture. This will really help you. Okay, so next 5 minutes, mute yourself. Don't make any background noise. Let's see how things are goes. Okay, interviews and things and stuff. You should know one theory first of all. Okay, which is hypervisor. And second thing, you should know what is the architecture of Docker. And third one, you should know what is Kubernetes and how it is different from the architecture level. Okay, that is very important thing to understand. Okay, quickly I'll tell you the concept behind, so everyone can easily connect. We all know when we take a hypervisor, right? We'll be having a hardware like that. Okay, on top of the hardware, we'll be having the either operating system or you will directly install the hypervisor application. On top of it, right, you will be having a number of virtual machines like this, multiple virtual machines like that. So what are the layers? This is your hardware. Hardware means what? Your CPU, memory, something like that. Okay, this is your hardware. On top of it, right, you will be installing your hypervisor application. Hypervisor means whom? VMware, ESXi, Hyper-V, those applications. Okay, VMware, ESXi, Hyper-V, those applications. These are your VMs. Okay, what is the advantage? So if the hypervisor is not there, right, there is no concept of virtualization. If the hypervisor is not there, if you go any environment, if you take 5-6 years ago, if you go any data center, there will be a physical server, right? On top of that physical server, we'll be installing our OS, we'll deploy our application. But today it's not like that. Okay, once the hypervisor has been introduced, we will be having a hardware. On top of it, we will have a hypervisor. This hypervisor will help us to create a multiple virtual machine from the single hardware. Multiple virtual machine from the single hardware. Here you can host your application 1. Here you can host your application 2. Here you can host application 3. So hypervisor helping you to divide your hardware with, virtually, and making sure to create multiple VMs. And this will lead you into deploying multiple applications. Literally cost saving. Okay. So why then? After the hypervisor, there's the next generation. There's something called Docker. So when you take a Docker, right, you will be having a hardware similar like this. Okay, you'll be having a hardware similar like that. On top of the hardware, right, you will be having something called operating system. There's something called operating system. On top of the operating system, right, we have something called Docker engine. We have something called Docker engine. How your hypervisor helping you to create a VM? In the hypervisor, in the Docker, this Docker helping us to create a multiple containers. Guys, the container 1, 2, 3, 4, 5, 6, like multiple container, right, which is allowing us to create. Okay, so hypervisor allowing us to create VMs, Docker allowing us to create a container. The reason why people are migrated from hypervisor to Docker, what is the reason behind? So when you ask me like that, right? Okay, when you ask me like that, your hypervisor is very expensive. Okay, the VMware license if you go, or a Hyper-V license if you go, that's very, very expensive. And the management server, right, to managing, VMware, vCenter or hypervisor virtual manager, thus that application itself will cost you a huge hardware consumption. Okay, due to cost saving and hardware saving, right, VR came into the Docker. When you come to Docker, right, it's purely open source. We don't want to worry about, buying a license and things and stuff. It's purely a open source one. And this is very lightweight in size, comparatively same hardware only we are using over here and here. See, we can host only 3 VMs here. In that case, we can host double the number of containers. We will be able to host multiple application on top of containers, guys. Okay, this is what all about. The difference between hypervisor and container, and where the Kubernetes comes. When you take a Kubernetes, right? So here there is no proper high availability in hypervisor and Docker, especially into Docker, there is no proper high availability. That is the reason we got a Kubernetes. Let me compare the architecture of Kubernetes. When you come to the architecture of Kubernetes, we have a concept called clustering based mechanism. Hope most of you are aware about what is the concept of clustering, right? Okay, Kubernetes cluster. What does mean by cluster? You will have a multiple hardware will be there, guys. This is a node 1. This is a node 2. I mean hardware 2. This is a node 3. This is something called hardware 3. Like that, you will have a multiple nodes will be there. Multiple servers hardware will be there. Okay, on top of these, on top of this node, right, you will have a layer, something like this. Okay, you will be having an operating system like that. Okay, each and every node has operating system. Okay, like this. You'll have a operating system. So this is your OS, and this is your OS. So each and every node in your cluster will have a OS. Okay. On top of the OS, right? Again, you will have a Docker. On top of it, you will have a, what is that? Kubernetes component, something like this. Kubernetes. On top of it, right, you will be creating a multiple parts like that. These are something called as a parts. Part 1, part 2, part 3, part 4, part 5, part 6, part 7, pod 8, pod 9. Like we'll be creating n number of pod, we can host our application. So this is how it differs. So Kubernetes is the biggest advantage since it's working in the principle of cluster-based mechanism. Even though if something happened to one particular, even though if something happened to one of my node, if looks like this is down, no need to bother. Still, we have a couple more nodes are part of my cluster. Still, we will be able to access our environment and things and stuff. Okay, so the cluster deploying Kubernetes cluster, we have various options are there, auto scaling options are all possible. I'll explain about it. Okay, this is the difference. This is the architecture. Yes, guys. So now tell me, like, if anyone has any doubt with this architecture, so why we have started using Kubernetes. Now everyone understand?
Yes, sir.
Yep, cool. So initial phases, hypervisor, then people are moved to Docker. There is no proper high availability Docker. So we are moving to Kubernetes. Even though, if you remember, last project 14 and project 15, we deployed all the application on the Docker only. I used to explain everything, the perspective of Docker. Now, if you go there, right, all of them, they are going to talk on top of Kubernetes. Kubernetes works in the cluster-based mechanism. So you will have multiple servers. Servers are here calling it as nodes. Here in the diagram, you can see node 1, node 2, node 3. Multiple servers. It can be physical server, it can be on-prem server, it can be cloud-based server, anything. Not an issue. We'll be installing the Kubernetes component on top of the nodes. We'll start use. Okay. So any questions, any doubt regarding this? During the explanation, I clearly said like to
Yeah, hi sir.
up the flow. Many of them unmuted. Now ask any doubt if you have.
So this is your uh,
Yes, Hari, I'm audible?
Yeah, go ahead. Your name, please?
Hari.
Yeah, your good name? It looks like Samsung here.
No,
Samsung.
yeah, that is a tab name. My name is Hari.
Your name also Hari, yeah?
Yeah,
Oh, okay.
actually, it's Haridas. In short, people call Hari. Yes. Yeah. My question is like when we use Kubernetes components, Docker we are using as a runtime engine, correct?
Correct.
Docker runtime.
Correct.
Okay. And
Basically,
whenever we use
yeah,
Docker on top of our physical machine, Docker having minimal base images, correct? Docker images having small sizes rather than ISO images we use in the hypervisor type, correct? So why I just wanted to understand how this Docker images are so small, they are able to manage in small size.
Yeah. So basically, there is no kernel. Another thing, if you take ISO images, example, if you take Windows Server or Linux or desktop OS, also if you take, unnecessary many applications will be there. In your local Windows laptop itself, if you take, you will have a default component like Internet Explorer will be there. Windows Media Player will be there. If you ask user, hey, will you use Internet Explorer or Google Chrome? Many of them will tell, hey, no, I am using Chrome only. But what happened, right? Unnecessarily inbuilt, the Microsoft is giving some inbuilt applications. There will be a calculator application will be there in your laptop. But people won't use it. They use mobile for calculating nowadays. They don't use Internet Explorer. They don't use default media player. They'll always install VLC media player. So these kind of, inbuilt application and softwares and library makes your normal ISO bigger in size. Where if you take a container image, right, it only requires what is needed to boot your container. If you need anything additional, you need to bring those libraries and applications and all. By default, it won't be there. It will be like a plain format. That's why it's very light in size.
Okay, got it. And does Docker container shares the base machine OS? Like if it is Linux, does Docker container share the base machine OS to run the container?
Linux based. Any Linux based, Linux kernel based Docker host will be the best option to create.
Okay, means Docker container shares the base machine OS.
Sorry, come again. Docker.
Docker container, if I am creating Docker container which is hosted on the Linux OS, okay, base machine
Yeah.
OS is Linux,
Yeah.
and on top of that I'm creating the Docker container. My
Okay.
question is our Docker container sharing the base machine OS, like it is
Correct.
sharing the
Correct.
hardware
Correct.
actually,
Correct.
correct?
Correct. Correct. Correct.
But
Yeah.
OS is also getting
Yeah.
shared or
Correct.
not?
Yeah. Yeah. It will be shared. There is something called kernel. It will be shared from our local host operating system. It will be shared.
So means in my opinion, any flavor of Unix we are using, means Linux is also a flavor of Unix. So already 80 to 90% of the OS is running, and we are just downloading in the form of Docker image some additional features, different flavors, additional features. 10 to 10 20%. That's why Docker is reloading fast. Is that correct?
Yeah, there is a technical term called kernel. Okay, the kernel is not there in each container. It will get it from the host operating system, host machines. One whenever any container need kernel related functionality, it will get it from the host operating system. That is the reason it's lightweight in size. Technically speaks.
Yeah, got it. Great.
Any other question? Any other doubt to anyone on the
Yeah,
architecture?
hello.
Anna?
I have one question that in the Kubernetes cluster image, there is one master node and there is other node. In the
Yeah.
architecture, is you are just drawing. There is only node on the top of that OS like that. The architecture is a little bit different as so in the website or like that.
Yeah. Good question, by the way. So currently, what I'm showing that is about Kubernetes is using clustering. Out of this node, right, one node will be the master node. Okay, remaining node will be considered as a worker node. We have a component available. Master node will do certain activity like uh,
Yeah,
kind of scheduler, controller,
controller.
the etcd, API
Yeah,
API controller, like components are there. When you take worker node, kubelet, pod creation,
With
everything will
proxy.
be, yeah, kube proxy, those things will be there in the worker node side. Also, people used to, some of them, we used to call it as a control plane, data plane. Control plane means your
yeah.
master node, data plane means your worker node. Yeah, that is comes probably in the project 17. Next project, it will come. Components and the architectural Kubernetes component we'll see in the project 17. Okay, this is just a comparison how it is differ from Docker, why it is providing high availability, because it's
Okay.
cluster based mechanism is providing high availability. That is what I wanted to clarify here. Master,
And yeah. And one other thing is that in the diagram you just showing that there is Docker on the Docker above is component. So here we use container, not Docker. Actually, what I know.
in the Kubernetes architecture you are telling.
Yeah.
Yeah, see,
They,
for working with the Kubernetes and pod, any one container runtime is needed. It can be Docker or it can be
Docker
RKT.
IO.
Anything,
Yeah,
any container runtime is fine. But right, a majority of people in market they are using Docker. So I also mentioned the same. Any container runtime, Kubernetes
okay,
runtime.
sir. No problem. I just clarify. Okay.
Sure, great. So yeah, many interesting questions and useful. These are really valid. So now hope many of you understood why we are moving to Kubernetes. Okay. Now I'm going to go back to this browser and the project. Here exactly where our project 16 coming to the picture. Okay, your company manages multiple environments. Right? Multiple environments mean it can be development, testing, and the production. Usually dev, test, prod. That is the hierarchy. Most of the project follows as environment. For the same set of microservice, you have application, same process you are being following: development, testing, production for microservices. Prevent the resource conflict and enforce access control, and the DevOps team decide to use the Kubernetes namespace. To prevent the resource conflict means, see, example, there is a person who newly onboarded to my project. There is a person called Narayan who newly onboarded to my project. Instead of deleting a test resource, he mistakenly deleted the production resource. Mean what will happen? Just imagine. It will be escalated, right? Instead of deleting test resource in your Kubernetes cluster, the person mistakenly deleted production. We can't do anything. We can't even tell to our client, hey, sorry. The person Narayan who new to my project, He mistakenly deleted this. This is a valid root cause. We can give it to our clients. No, right?
This is disaster, sir, actually.
So that is the problem actually. That's what they are telling. Prevent resource conflict or accidental deletion or enforce access control. DevOps team, as a DevOps team, you and me decided to go with namespace and Kubernetes. Okay. Now what is the plan is, each environment get its own namespace, like a test, dev, prod, something like that. In the dev namespace, right, developers are free to deploy and test their application without affecting the production environment. That is the target. So in the Kubernetes cluster, we are going to set up some environment development. If you have any dev related resources, put it in the development namespace. If you have a testing related component, right? Yeah, they mentioned here, put it in the test namespace. Don't touch the production namespace. Production namespace will always have a production running critical application will be there. Like that, inside the Kubernetes cluster, right, we are going to logically group the resources. Not physically. You have one cluster, you are going to logically group the resources. Okay. That logical grouping is something called as a namespace in Kubernetes. Logical grouping of this resource. Wait, these are the resources for dev. These are the resources for prod. These are the resources for testing. So within the cluster, we are logically grouping, right? That is something called namespaces. That's what we are going to do. Okay. For example, the team deploy a simple pod running web server in the dev namespace. Then same application once tested and approved, later deployed into the prod namespace. Okay. So the another benefit is you don't want to directly deploy any resource into prod. First you put it in the dev. Once you test it in the dev namespace, then finally if everything working good and working perfectly, then you can deploy it in prod namespace. Okay. So this setup allows isolate resource usage and monitoring. So end of day, we'll come to know how much we are spending for testing per month, how much we are spending development per month. So that kind of differentiation we would be able to see. If possibly we wanted to cut down the cost and all, it will be easy for us to plan. Imagine if you are not having this namespace concept itself, accidental deletion may happen with the resource. Anybody can touch any resources in the cluster. We won't be able to properly monitor how much we are spending for testing, how much we are spending for development for product. That cost monitoring and all is not possible. And again, finally, the resources will not be organized. If namespace is not there, right, it will be like a garbage. It's not like it's managed properly. After a few point of time, if you are planning for clean up those resources also, you won't be able to do. Oh my God, whether if I delete this resource, something will impact on the production. Because namespace is not there, you are not properly organized. So to avoid all those issues, right, we can have a namespace in place. Okay. Separate access permission for the different team. Even see, as I said, right, Narayan is the person who newly onboarded to my team. I will give access only for test namespace for him for 1 month. Once he familiarized with all the project terms and things, then I'll slowly extend the permission to dev namespace. Once he, get all the hands-ons, once I got a proper, confident on him, I'll provide the production namespace access. Okay. Clean organizations workloads. Yeah, we'll have a clear picture what things are going on and everything. It will be cleanly organized to the resource. So this is why we are using namespace in the Kubernetes space. These options are all not there in your Docker. Understood? Any doubt so far? What is namespace in Kubernetes? Great.
Yeah, clear.
Perfect. Now tell me, I need one Kubernetes cluster now for free of cost. Lifetime. If I create a Kubernetes cluster in AWS account, right, they'll charge me. Even though it's free tier account, still they'll charge. Can anyone tell me the alternate option for me?
You can go the Minikube or else you can go for the kind cluster.
Very good. Minikube unit installed in the local machine, right? Very good.
Yeah.
Okay. Any other option?
Or else you can go for the kind cluster. It will be
Docker. There is
the
also available Docker.
yeah.
What is that? Can you repeat?
Docker IO.
Docker IO. Okay. Where you can find the Kubernetes cluster we can create?
Yeah.
There is
Then
there is 4
then,
hours available.
then after you can install the client cluster, then it will be work.
Is it free?
Yeah, is it free?
Okay, great, fine.
We can use killer coda as well.
That's the easiest one, which I'm going to show you. It's information for many people. What others said, that's also works, but there is a link is there. I'll share it with you all. If you copy the link, if you put it in the internet, you'll get the cluster ready. Loading. Yeah, within 3 seconds, your cluster is ready. So that's a site called Killer
Sir,
Coda.
it is for 1 hour, but in the Docker that is 4 hours.
Here also you can get 4 hours, but further you need to be member. You need to purchase the premium plan. Practicing only. We are going to do the practice only, right? 1 hour is fine. If this time is out, we'll refresh. We'll get the new session. Okay. Anyway, whatever people comfortable, yeah, go with that. This is one of the option I'm telling. You have better alternates also online available. You can go there, no problem. Okay. So Docker IO is suggesting, yeah, explore that also. Anyway, end of day everything same. Online simulator. We can practice our command. End of day, if you learn from any one source, that's good. So if you come to the Killer Coda, right, it's an online, platform. It's kind of a SaaS service. Backend Kubernetes cluster gets created. Front end will use that application and all. Okay, that is the intent. So here we are going to talk about Kubernetes things and stuff. I know that many of you new to Kubernetes. How many of you new to Kubernetes here? How many of you new to Kubernetes world?
Me.
Okay, one person. Okay, Naresh raised his hand. Okay, he also new to Kubernetes. Yeah. Raghav also new to Kubernetes, seems. Great. Anandaraj. Almost 4 people are new to Kubernetes. Seems like others are already working or having some basic idea about Kubernetes, maybe. But yeah, some of the people are new to Kubernetes. Anyway, when you are new to Kubernetes, right, nothing to worry. You need to remember there is a command kubectl. This is the tool mostly you will use. This is a tool, right? Mostly you will use. So for 90%, right, to work with Kubernetes, so command lines. This is the command is mainly used for. Okay. And using this tool, right, now I'm going to run a get command. kubectl get nodes. There's a command available. This command, right, will display how many number of nodes taken for creating this cluster. So now you can see 2 nodes is available. 2 nodes is showing here. Later, right, if you have a multiple requirement, you can keep add the nodes also. Okay, depends on it. But as of now, the cluster is created with the 2 nodes. Cluster is created with the 2 nodes. Now I'm going to show you one more thing. kubectl get pod. So as of now, no resource found. This is a brand new cluster, right? So we don't have any pod available. We can create the pod if you want. Okay. So I don't know how many of you remember in the previous project we discussed about the Docker creation command, that is Docker run. In Kubernetes, right, you can use kubectl run, name of your pod, maybe pod1 -- image. So pod is getting created. If you see the pod is getting created, container is creating, then it will be pod will be ready. Again, another few seconds. Yeah, now it's showing like pod is running. Okay. Now kubectl get pod, we are able to see the pod. Before that, we are going to see kubectl get namespace. Okay, you can see these are the default namespace which will come along with your cluster. Okay, default kube node list, kube public, kube system. These are the, when you create a brand new cluster, right, these 4 namespaces will come. Each one has its own, responsibility. And the default namespace, this is the one what we talked about. Okay, these all the resources, right? Currently will fall under default namespace. Now our task is to create a 3 different namespace for dev, dev, test, prod. Okay. kubectl create namespace. Either you can type like a namespace or short form also available. You can use namespace. NS also it will take. kubectl create namespace. Dev. Okay. kubectl create namespace. Test. kubectl create namespace. Prod. Okay. We have created. Now along with the existing 4-5 namespaces, now our namespace also will get created. Okay. Now I'll show you. kubectl get namespace. You can see dev, prod, test. So this is the best way of handling and managing your infrastructure, guys. When you are coming to the Kubernetes, very first thing you need to set up your namespace. Very first thing you need to set up your namespace. Now, if you see kubectl, run pod dev, kubectl run pod -dev -image nginx -n dev. When you add this kind of tag, right? When you add this kind of tag, your resource will be provisioned to this particular namespace. Your pod, right, will be provisioned to this particular namespace. Okay. When I hit enter, see the pod get created. Now, if I simply give kubectl get pod, you won't able to see this pod dev. Because by default, it will display whatever the resource available in the default namespace. If you wanted to see the pod in the dev namespace, you need to use this -n dev. Look at that. You should be able to see pod dev is running and available under the dev namespace. All of you clear? Any doubt in this commands?
No.
Yeah, what about others?
No.
Okay. Nobody has any doubt, right? Good. Feel free to ask if you have any doubt. So now, what are we going to do? We are going to create a couple more parts in the prod and test namespace. Okay. kubectl run is the command to create a new pod. kubectl run pod test namespace. Okay. I'll create prod namespace. Okay, I've created the resources in that particular namespace. Now kubectl get pod. Now it will show from the default namespace. You wanted to see from test namespace, give the attribute called -n test. If you wanted to see from prod, you can give prod. Got it? Any doubt with the commands? Anyone ask any questions so far?
Is namespace is the same concept like a Docker network concept? Like Docker network, in particular network, if we have to create the Docker container, in that case, we create the container with -- network and network name tag. Likewise, here we are creating with namespace tag. Means my question is, if I create some pods in dev namespace and if I create some pods in prod namespace, are they able to communicate with each other by default?
Okay. So will you be able to set some resource allocation quota and all using that in Docker container level? If any resource gets created in the test network, my pod has to have the limitation. Only the user Narayanan will have the access to the test container, will be able to make that restriction and all?
No.
No, that is why namespaces it has little more, much better than your Docker level. There is no proper things. Yeah, of course, I agree. When new products comes, right, we'll have the enhancements. I agree with that. Yeah, that is how namespaces differ. We would able to have the limitation restrictions. In the test namespace, right? If I feel like, hey, oh my God, I'm spending so much of money, I can have a restriction. Resource quota, I can restrict it. People who are creating testing, within that quota only, they can test for a month. Like that, I can define it. People who coming newly to my project, right, I can restrict, okay, he has access only to that test namespace for this month. Like that, I can control it. Many more features are there. Yeah. So that's a major difference. But however, this is the concept behind. Okay, that is what people are trying to say here. So, general scenario, why people are migrating Docker containers to Kubernetes? Why people are migrating to Docker container to Kubernetes? Anyone knows the answer? I think Narayan, you
Yeah.
already. Yeah.
Yeah,
It
One
is
by
in
one
a
go. One by one go. Now,
scaling. Docker container does not provide the auto scaling and also self healing call capability. Like if container is down, it is container will not create it automatically. These things.
very good. Any other differences?
yeah. Kubernetes gives auto healing, auto scaling, and enterprise level support.
Very good. Any other differences?
The Kubernetes has some sophisticated tools like readiness probe and liveness probe, which is not there in Docker
Very good. Very good. Any other
or Docker
points?
Swarm.
Why we wanted to migrate from Docker to Kubernetes?
Other best features of Kubernetes that we don't create identical infrastructure during deployment. Using Kubernetes, we can deploy on the same resources that save the much cost in the organization also.
Okay, great. So here in your organization, if you are using Docker container, why you need to migrate to Kubernetes? These are the answers. You can even take this for in interview. People who doesn't know the difference, listen to me. Definitely you will get such questions in the interview. Okay, why Kubernetes is better than Docker? Why you are migrating? All those things. When container is crashed, right? Someone has to manually restart it. So in Kubernetes, not like that. Something crashed from the deployment, it will automatically recreate it. Self-healing capacity is higher when come to Kubernetes. Okay, no manual intervention required when anything crashed the pod level. There was no easy way to scale the container during peak usage. In Kubernetes, right, you can increase the pod count, replicas count. You can reduce it instantly. Those things, right, we can aggressively we can do it. But in containers, right, it doesn't possible in the peak hours. So where in Kubernetes, you don't even require a downtime to increase the replicas in your, increase the number of pods capacity, right? You don't even require a downtime, but which is very difficult when come to Docker containers. Managing networking between container became complex. When you have a multiple container, managing the networking, these things and all become very complex. Updates to the running container record stops and app leading to a downtime. Okay. But in Kubernetes, right, we can update the configuration and the deployment. We can create a new pods. We can eliminate the old pod, which doesn't mostly require what do you call downtimes. Developer accidentally affected the production container due to lack of environment separation. This is what I said. There is no environment separation like the dev test prod. There may be more chances. People like who newly onboarded to the project, right? They can mistakenly touch the production containers. If you move to Kubernetes, you have a problem to solve this. Automatically restart and self-healing of any failure containers in the pod level. Horizontal scaling based on the load. You might be discussed about auto scaling in AWS. Similarly, we have a HPA, horizontal pod auto scaler, is available in the Kubernetes. If any pod seems like either it's going to down or overutilize, it automatically create it. namespace based separation for Dev test to product. Just before we discussed, right? This is not there in the container level. Built-in service disaster discovery to simplify the communication between the services. We have a service available, cluster IP, node port, load balancer, like various services available. Using that, they made it very simple in terms of making sure the communication. Rolling updates to the deploy new versions without downtime. You don't require any downtime. Okay. So, yep. These are all the things you all of you to keep in mind when come to the migration part from the cluster container to Kubernetes.
Kubernetes has an open API, so it can be integrated with any monitoring tool like Prometheus and Grafana.
Prometheus, Grafana, New Relic.
New Relic.
Even Kubernetes itself having on a basic dashboard, which I don't have a much functionality, but yeah, decent one.
Yeah, can
Okay.
I use AWS API for that routing access outside EKS cluster?
Sorry, come again. I am busy in finding the pushkar,
Yeah.
removing.
Can I use AWS API for the access EKS? If I have an application on EKS, I wanted to access the application through API gateway. Like AWS is provided the API gateway is there.
Yeah.
Yeah. I wanted to access to EKS applications, containerization application. How should I achieve?
Yeah, probably you can expose it with the service. Okay. Kubernetes service. From the service, right, you can get into the deployment.
Yeah. Services is there, but I want to do expose. I don't to use the any services. I want to access through the API gateway.
That part I need to check really. You share your requirement, I'll check and get back to you. Okay.
Yeah, sure.
You just to ping me your requirement in the chat. I'll check and get back to you. Okay. So coming back to our discussion, we have created the dev prod test namespaces are available. So if you go kubectl describe namespace, if you take anything, we'll give you the more data about it. Okay, name, label, status. There is something called resource quota, as I mentioned, right? You can set up a resource quota available. So probably, I'll share one document which has all these resource quota and everything. You can explore it if you have a time. Namespace, yes. Okay, this is the official document which I have for namespace. I'll forward with you all here. If you go, we have more info about namespaces. Okay, what is the difference between each namespace? And if you wanted to see what all the resources can be grouped using namespaces, not that can be found here. And if you wanted to set your namespace as a default namespace, what you need to do, how to set the context. Okay, that part you can see. Deleting the namespace, and here, yeah, this is exactly what I'm trying to mean. Using this, you can manage your resources, manage memory, CPU, API resources. We would be able to do it if you configure this Kubernetes. Namespace restrictions, we can limit the memory, CPU usage, everything. Okay, I'll forward this document to the participants. Actually, last week I supposed to share the dumps. I committed, I collected the email, I had to share, I forgot. Today I'll share it. So people who are attending session, who need this document, share your email in the chat box. I will forward this document. This has more information about the specific Kubernetes namespace where you can try. Fine, guys. Apart from that, I'm starting the new AWS DevOps batch and Azure DevOps batch. Okay. From this weekend onwards, the weekend session. If any of you wanted to learn AWS DevOps from the basic with real-time project scenario, just to do, ping me in WhatsApp. I'll add you in my group. Okay. People who come from my community, weekend community, I can give you, 5,000 discount from the actual course fee. So that will benefit you, I believe. And yeah, about my quality of training and all, the way I teach. It'll be, 2.5 months to 3 months of course. Advanced, we'll go deep dive about AWS DevOps. Or if you wanted to go a different technology like Azure DevOps, yes, both we are starting. Okay. Either if you wanted to join, yeah, ping me or your friends or your colleague, or you wanted to refer, that also great, thing for me. Okay. So if any one of your colleague or friends interested, please let me know. I'll talk to them. I'll add them in my group batch. Okay, I got few people's email ID. I will probably just, copy the email ID. This is for namespace. Okay, guys, probably thank you all. Upcoming sessions, right? Since it's our first Kubernetes batch, sorry, Kubernetes project, I'll try to add a few more things. Okay, that's what I'm touching very light. Upcoming week, we'll try to add more scenarios. Okay. So thank you all. Bye.